So this is not in your book, but just a real warm-up here. So let's look at this polynomial you see up here. What is the degree of that polynomial? Yeah. I'm hearing lots of numbers. 5 is going to be the correct answer today. Okay. So 1, 2, 3, 4, 5. Okay. That is what kind of number? That is an odd number. Okay. That means it's either going to do this or this. Okay. What's the leading coefficient? Yeah, -1. That's what kind of number? That's a negative. So that means, what does this graph look like? That graph is going to go up. So it's going to go this way and this way. Okay. That's what this graph does. So in limit notation, that means the limit as x approaches -infinity of f of x. As I go to the left, where does my y values go? They go positive, okay? As I go with my x values to the right, where do my y values go? They go to -infinity, okay? Before, I always wrote that down for you. What if I didn't write this down for you? You'd need to be able to write this down. There's never an equal sign here. If you write equal infinity, that's bad math, okay? X-intercepts. I haven't graphed it, but what are the x-intercepts? It looks like 1, 0. What is -1, 0? Yeah, 2, 0. And -3, 0. Okay. What's the y-intercept? How do you find the y-intercept? You set x equal to 0, so that's going to be -1 squared times 1 times -2 times 3. That's going to be 6. So the y-intercept is 0, 6. Is there any multiplicity? Do any of those roots occur more than once? Yeah, there is a multiplicity of 2 at x equal what? At x equal 1. There's a multiplicity of 2 at x equal 1. We've always written it in this form. Yes? Well, the multiplicity happens at the root, not the factor. Okay, so it's at that point. So it's at the point. You could write it happens at 1, 0. That's okay. Okay, that's the same thing. This is enough information to get a good graph now. Okay. So your roots are at what? -3, -1. So let's see. 1, 2, 3, 1, 2, 3. So what's special about the root at 1, 0? What happens? I do not cross the axis. So at 1, 0, I will not cross the axis. And what are my other roots? My other roots are at -1, which is right there, -3, and +2. Okay. My y-intercept is at 0, 6. This graph starts up in the upper part. Is it possible to go through this point, this point, this point, bounce, and then come back down here? Yeah, all of that is within the realm of possibility. So this graph does this. That's all it can do. Okay. This needs to be very solid. Okay. So it pulls together a lot of information, things that we've done in the unit. Now another kind of problem is, suppose I give you the graph and ask you questions. Is this an even degree or odd degree polynomial? Even degree. Leading coefficient, positive or negative? Positive. The end behavior, the limit, as x approaches -infinity of f of x, where do the y values go? They go to +infinity. And the same answer, the limit x approaches +infinity of f of x, the y values also approach +infinity there. What are the x-intercepts? -3, 0, -1, 0, and 2, 0. Okay. What's the y-intercept? Yeah, 0, 4. Is there any multiplicity? Multiplicity, you indicate graphically, it means that what happens? Yeah, so it means I do not cross the axis. Do you see a route where I'm not crossing the axis? Yeah, there is a multiplicity of 2 at x equal 2. And then now, what is the equation of this graph? Okay, this graph is f of x. Yeah, on even multiplicity, okay? You don't know that, I can't expect you to know that this was a fifth multiplicity. So you're looking at 1 and 2, okay? Multiplicity 1 and 2. You can't graphically tell the difference between 2 and 4. It flattens out a little bit more, but I can't expect you to know the nuance there. F of x equal, there's a leading coefficient. What are the factors? X plus 3. What else? X plus 1. X minus 2. But what's special about the x minus 2? It is squared because it's multiplicity 2. Okay, it has to have an even square because I do not cross the axis there. What degree is this? Fourth. I needed it to be what? Even degree, that's right. Okay. How do I figure out what the leading coefficient is? Use the y-intercept. The f of 0 is equal to 4. So that means that 4 has to equal a times 3 times 1 times negative 2 squared. So that is what? 4 times that's 12. So 4 equal 12a, which means that a is equal to 4/12 or 1/3. So this equation is f of x equal 1/3 x plus 3, x plus 1, x minus 2 squared. Okay, that's where we ended up when we left for spring break. So as you were doing this on the beach, I'm sure that you kept up with where we were. That's sarcasm right there. Or maybe you were skiing. I don't want to be, we'll go from there. Okay. Last topic of our polynomials unit. So it seems to be a lighter topic, but very important. And again, what we're going to do, what you see us do today on the TI Inspire, you'll need to do one of those problems on Thursday. Just a way of breaking up the information on the test. So you went for a hike, okay? You start right here, and let's just say that you end right here. Don't ask me why you didn't make it down the mountain, but let's just do this, okay? So that means that you do this, okay? Now, can you look at this and say there is a spot on that hike that I was higher than any other spot on my hike? Yeah. So no, I didn't do a good job on it. Let me make it a little bit clearer. But you can see it's right here, okay? That is the highest point. Mathematically, we would say this is the absolute what? Maximum, okay? So in all of my trip, that was as high as I went, okay? Is there a spot on this trip that I was at my lowest altitude possible? That would be right here. This point would be called my absolute minimum. Okay? So absolute maximum, absolute minimum. Now look at all the other peaks and valleys, okay? What if, for example, what if my journey went from here to here, okay? This would be a what? If I started here and ended here, this would be a what? That would be a maximum, okay? So, but it's not the highest of my whole trip. So what we say here is that this point right here is what we call a relative maximum. Meaning that I could construct a neighborhood right here, and it is the maximum of everything that happened within the blue, okay? So it's not the maximum of my entire hike, But if I went from here to here, it would be a maximum. Same thing right here. If I only consider this portion of the journey, this would be a what? A relative minimum. It's not the absolute, but for that area, it is. So this point right here would be a relative minimum. So this is just some terminology you'll use in pre-calc and in calculus. Just trying to get you exposed to it right now. So maximums and mins, okay? Absolute max means the highest point. I can put my finger on a spot. That is the highest point of the whole journey. No point is higher. Absolute min, I can put a point here. There's no part that's lower. So if I can identify the absolute minimum, every other minimum you see here has to be a what? Relative minimum. If this is my absolute maximum, every other little peak that you see is a relative maximum, okay? So identify your absolutes first. Anything you have left will be a relative max or min. So let's take that to our polynomial here. Let's look at this first polynomial here. Now, anytime you do not see arrows, at this point, you know to assume that happens, okay? What's the degree of that polynomial, even or odd? Even. Its leading coefficient is what kind of number? Positive. Is there an absolute minimum? Is there a point on the graph that is lower than any other point? Yes. And lucky for you, it is labeled. So minus 0.74 minus 7.4. That is my absolute minimum. Now, I tell you here, there is no absolute maximum. Why is there no absolute maximum? It keeps on going. Never say the absolute maximum is infinity, because infinity is not a number. You can't put your finger on it and say, there's the absolute maximum infinity. There it is, okay? Can't do it. So there is no absolute maximum in this problem. Look at the next one. What is the degree of this one? This one's even. It points down, okay? Leading coefficient, positive or negative? Negative, okay? Absolute maximum. Yeah, negative 2.47, 5.1. And in this graph, there is no absolute minimum. Why is that? It continues to go down to negative infinity. That means there is no number that I can name and put my finger on that's the lowest spot of the graph. Because once you do that, it keeps going. It never stops. There is no absolute minimum for that graph. So here's the terminology we've been using here. Start with absolute. Absolute minimum, a point that serves as the minimum value for the entire domain of the graph. You don't really need to memorize that. If you think of that hike we just took, what's the lowest spot of the whole journey? Absolute maximum, a point that is the maximum value, the highest point for the entire function of the graph, okay? If you can identify the absolute max and absolute minimum, any other peak or valley is going to be what kind of minimum or maximum? Relative, okay? It means that it's a maximum if you look at that particular area, okay? Now, something else we need to talk about is increasing or decreasing. So what we need to think about with this is think about a roller coaster. So if you've got a roller coaster, typically you start on the roller coaster. So those our roller coasters always go left to right here. Usually the roller coaster will go up. Is my height increasing or decreasing? Increasing. I usually get to a point, which is some kind of maximum, and then I start doing what? I start going down, which is, instead of increase, that's decrease, okay? Then I usually get somewhere else, and then I will start increasing, okay? So we'll look at it as if I go from left to right, if my y values are going up, I'm going up the roller coaster, I'm increasing. As I travel from left to right on the x-axis, if my y values are going down, I'll say that that's decreasing, okay? These topics become very important in pre-calc and calculus. So functions can have different intervals where they increase, decrease, or even where they're doing neither, okay? So that's these are the new topics that we're talking about today, and I think they should come together pretty relatively easy. So let's look at this polynomial. The degree of this, is this even or odd? Okay, it's odd degree. Leading coefficient is positive or negative? It is negative. Okay. Is there an absolute maximum? No. Why is there not an absolute maximum? It continues to go up. It's not bounded there. So there is no absolute maximum. Don't write equal infinity here. Just write no, none, nada, empty set, null, whatever. Okay. Is there an absolute minimum? No, because this graph continues to go all the way down unbounded. So if I have any max or mins, what flavor will they be? They're relative, okay? Well, I said there's no absolute max or min. So any max or min that I have has to be the flavor of relative, the kind, okay? Not that they're edible, okay? I wasn't suggesting that. So that means this is a max or min? -4, -8. Yeah, that's a relative min. What is this point right here? -1, 1.6. That's a relative maximum, okay? What is this point 1, 0? Yeah, that's a relative minimum. What's this point 3.1, 3.3? Yeah, that's a relative maximum, okay? Guys, this is pretty intuitive, right? I mean, I'm looking at the peaks and valleys and I'm just naming the points, okay? Now, some things that I'm not going to spend a lot of time because you learned them last semester. What's the domain of this function? The domain is the set of all what? X values, okay? So, X values, what are the X values on this polynomial? Yeah. -infinity to infinity. All the polynomials, the domain is -infinity to infinity. See, these things, it's going to keep on going, so there's no limit there. What's the range? The range is the only time you are ever allowed to look at which axis for your interval. Which axis you look at? The y-axis. So to find the range, what's the lowest y value this graph obtains? What's the lowest y value? -infinity. What's the highest y value? Yeah, so this range is -infinity to infinity. Now, intervals of increase, decrease. This is where you have to pay attention. These intervals are going to be on which axis? X or Y? X, because the only time I let you look at the Y value is what? The range, and we've already done that, okay? So think of the roller coaster. This roller coaster starts out here at -infinity. So as I travel on the x-axis, am I decreasing? What's the function doing as I go from left to right? Am I getting lower or higher? I'm going lower until I get to where? Until I get to there, right? Then what am I going to start doing? I'm going to start going up. I'm going to go up until I get to where? Right there. Then what do I start doing? Then I start going down until I get to this point. Then what do I do? I'm going up again until I get to whatever this number is. And then what do I do for the rest of this roller coaster? It's the roller coaster to hell because it just keeps going down and it never comes back up at this point. So I am increasing, decreasing, increasing, decrease, increase, decrease, increase, decrease, okay? That's what's happening. These are X intervals. Now you just have to name these intervals. I mean, you can look at this and tell it goes down, it goes up, it goes down, it goes up, it goes down. I want to put that in mathematical terms. So this first interval is an interval of decrease. What is this interval right here? It starts with -infinity to where? What's the X value? -4. Remember, I am only looking at what kind of values here? X values. I'm not looking at Y values. So it is decreasing from -infinity to -4. Then what does it start to do at -4? It starts to increase, and it will increase until it gets to the X value of what? -1. Okay? Then what happens at -1? It starts to what? Decrease from -1 to where? Yeah. So from -1 to 1. It decreases, and then what does it do? At 1, it starts to increase until it gets to 3.1. So that's from 1 to 3.1. Okay. And then what does it do at 3.1? It starts to what? What? Decrease. So 3.1 to what? Okay, someone said it, and that's what someone said -infinity. When you said -infinity, you switched to looking at what axis? You looked at y. So people will say, oh, it starts to decrease from 3.1 to negative infinity. So you were on the roller coaster to hell. You need to stay on the x-axis. So this interval is 3.1 to infinity. It's on the x-axis. So that's the tricky part here, is that when you look at these intervals of increase or decrease, you stay on the x-axis. You travel left to right. So when I start over here at negative infinity, I decreased until I got to -4. I increased from -4 to -1. I decreased from -1 to 3.1. I increased from -1 to 1. I increased from 1 to 3.1, and I decreased from 3.1 to infinity. So you stay on the x-axis for that whole interval, because the only time you talk about the y-axis is right here on the range. Okay, so everything else is x-axis intervals. Yes. Let's do another one. Hopefully it will sink in. Okay. Let's look at this guy. What is the degree of this? Even or odd? This is even. Okay. Leading coefficient is what? Negative. Okay. Is there a point that is the highest point of that graph? Yeah, I've got 2 points that are absolute maximum. They're both the same height, right? Okay. So this is what, 1.381 and 3.621. So I've got 2 absolute maximums. Okay. Is there an absolute minimum? No. Okay. So I've dealt with both of my absolutes. If I see any other max or min, it has to be what kind? Relative. So I've got this taken care of, this taken care of. This is a relative what? Minimum. So there's a relative minimum at 2.5, negative 0.563. There is no relative maximum there. What are the x-intercepts? 1, 0. This is where I was expecting feedback. 2, 0. 3, 0. 4, 0. Okay. What's the domain of this? What's the domain of this function? Yeah, negative infinity to infinity. The range, the only time I ever let you look at what axis? The y-axis. So my y values start at where? They start at negative infinity, but they only go up to where? 1. So negative infinity up to 1. What will I put right after that 1? A bracket. See, you guys could be teaching this today. Huh? Where did I get what? Right here. Y values start at negative infinity, but they stop at 1. They don't go any further. Range, tell Kyle, the range is the only time you look at the y-axis. You can. It's still a function because it passes the what test? The vertical line test. Okay. So, okay, now the other thing that's new here is what are the intervals of increase or decrease? Okay. As you're starting this out, it may be helpful just to say, let's just look at this whole function. Start from left to right. I start traveling out at negative infinity. Am I increasing or decreasing as I go from left to right? I'm increasing. I do that until I get to whatever that point is, which is what? 1.38. And then what do I start to do after that? I decrease until I get to this point. Then what do I do? I increase until I get to this point. And then therever after, I'm decreasing. Okay? How many intervals do you see there? I just marked off 4 intervals. I got 2 intervals of increase, 2 intervals of decrease. So tell me, what's the first interval of increase? Negative infinity to what? Yeah, 1.38. X values only. This is not the range. Okay, the next interval is a decrease. What is that interval? 1.38 to what, 2.5? The next interval is an increase. It's from where? Yeah. So 2.5 to 3.62. The next interval is a decrease, and that's what? Yeah. 3.62. Why did I not write negative infinity? Yeah. You guys should teach fourth period, okay? So I can't, I'm recording it. I can't say that on the recording. They may watch this. Come on, at least they could copy stuff, Kyle. I mean, okay. This is the kind of problem you're going to see on Thursday, last 20 minutes of class when we do the TI Inspire. So, look at this problem. Would you love to use synthetic division on this problem? Why not? Why not? What are the possible rational roots? Yeah, it's the possible rational roots are what? 128 over 32. Factors of 128. Does that look harder than the ones I've given you? Yeah. So this is why we're bringing out the TI Inspire for this one. So you should be able to. I can give you this without a graph, and you should be able to graph this and come up with this information. So let's do that. So let's just create a new. This is going to be a graph page. Okay. So someone tell me what is that polynomial? It's what, 32? Yeah, it's a new document graph. Okay. So 32x to the fifth, was that it? Fourth. And then what? Minus 192x cubed. Plus what, 4? 416x squared. Huh? Minus, 384 x. And then what, plus 128? So is this what you have? 32x to the fourth minus 192x cubed plus 416x squared minus 384x plus 128. Okay, what is a key skill when you're typing this in the TI Inspire? Don't mess up. Okay, so I mean double check what you put in there. So there we go. So this is our polynomial. Okay. Now, does this look like the best graph to work on? What looks like it's not inviting to work on? It looks to be too squunched up, right? That's a mathematical term. So we can handle that with menu, just like we did back in data analysis. Window zoom, window settings. So it looks like my x values are going from negative 10 to 10. There's a lot of blank space in there. Why don't I cut some of that out? So window zoom, window settings. Let's just go from, say, like negative 4 to 4. What does that look like? Well, I could even go further. So let's try that again. So it's just a trial or error. Let's just do, well, yeah, negative 1, sorry. I'm demonstrating this trial and error part. So yeah, negative 1. Oh, again, with this trial and error part. So there we go. Now, this looks much better to deal with, okay? So now, I want to be able to answer questions about this. So this is going to be, it looks like a relative, usually an absolute minimum, right? And this looks like an absolute minimum. This looks like a relative maximum. These also look like what? They're the x-intercepts, okay? So how do we find all of these things? Your calculator can do all of this for you, okay? So menu, analyze graph. If I pick maximum, all I have to do is click to the left of this thing and to the right of this thing. And it tells me there's the maximum, okay? So again, I'll do that again. So let me remove this. Well, this is a relative. This will be. I have to give the intelligence that it's a relative maximum. So so let's do that again. Menu, analyze graph. If I pick maximum, it's asking for me to pick somewhere on the left and the right, and it will calculate numerically what that maximum point is. Okay. Now, what do you think I would do to find this point right here? Menu, analyze graph. I got a couple choices. I think it's a 0 and I think it's a minimum. Let's try minimum. So click left and right of that point. It gives me that's the minimum. Okay. If I wasn't sure if that was a 0, I could say analyze graph 0. Click to the left or the right. I get the same thing. So that is a 0 and a minimum. Yeah, I'll do the other side. Yeah, there'll be 2. Pardon me? Let's go to the other one. So menu, analyze graph minimum. Come over here. I get 2, 0. Okay. So that's the part that you need to be able to do with your calculator. Okay. It's not rocket science, but you need skills on the calculator trying to increase those proficiencies. So does this graph have an absolute maximum? No. Does it have an absolute minimum? It's got 2 of them, 1, 0, and 2, 0. What is the degree of this polynomial? 4. How many roots does it have? No. 4. If it's a 4th degree polynomial, it has 4 roots, okay? Some may be real, some may be complex. What do you know about these roots that happen right here? They have what attached to them? Starts with an M. Multiplicity. There's a multiplicity of 2 at these 2 roots that you see right here, okay? So all of this information comes from looking at the graph, okay? So this is a replication of what was on that screen. What's the degree of this polynomial? We know specifically it's 4. That's even. What's the leading coefficient? 32. Positive. Absolute maximum? None. Okay, nada. Absolute minimum? It looks like it's going to be at 1, 0 and 2, 0. Okay. Is there a relative maximum? Yeah, that's at 1.5 and 2. Okay, is there a relative minimum in this case? No, I mean, I've already got these 2 minimums are absolute. There's no other minimum, okay? Now, let's look at this graph. As I travel from left to right, okay, I start over here. Am I increasing or decreasing? I'm decreasing. Look, you're starting way up here. You come down. So I'm decreasing. When I get to that point, what do I start doing? Then I start increasing until I get to that peak. And then I do what? I decrease until I get to that valley. And then I do what? I increase all the rest of it. So it's decreasing, increasing, decreasing, increasing. So these intervals are using which axis? X, not Y. So this first interval of decrease is what? Yeah, negative infinity up to 1, okay? And then what happens after I get to 1? What do I start doing? I increase from 1 to what? Yeah, 1 to 1.5, okay? And then I start doing what at 1.5? I decrease from 1.5 to what? To 2. And then once I get to 2, what do I start doing? I start increasing from 2 to infinity. This is stuff we did last semester, these intervals. So was there a relative minimum? No. What are the x-intercepts? X-intercepts. 1, 0 and 2, 0. Okay? What's the domain of this function? Yeah. Now, the range. Range, the only time you ever look at what? The y-axis. So let's look at the y-axis. Are there any y values down here? What's the first y value that you see, Kyle? 0. Come on, Kyle, you start down here. There are no y values. You don't see y values in this graph until you get to there. What is that point? Yeah, so 0 to infinity. There's always a parenthesis around infinity. What's going to go around that 0? Yeah, there we go. That's the range. Now, is there any multiplicity? Yeah, so I didn't ask that, did I, on your page? So just pretend like this was the test. There is a multiplicity of 2 at x equal what? 1? How can I look at that graph and know it's multiplicity of 2? It doesn't do what? Doesn't cross the axis. There's a multiplicity of 2 also at x equal 2. It crosses the axis, okay? Well, this one only has 2. No, if it crosses the axis, that's multiplicity of 1. So if it did something like this, you know, there's a this is just x plus 1, and this is x minus 2 squared, okay? You know this, Kyle. So, yeah. So what I want to do real quick, let's look at one in your homework just to make sure we're getting this TI Inspire thing down. So let's look at one that's using your TI Inspire. How about this one right here? Okay, guys, let's do this problem in your homework right here, this 2x to the 5th. So let's enter that in. Problem number 2 says use your TI Inspire. 2x to the 5th minus x to the 4th. Plus x cubed minus x minus 1. Plus x cubed minus x minus 1. Now, look at this graph. Is there an absolute maximum? Absolute minimum? What's the degree? The degree is 5. How many roots are there? 5. How many do you see? How many roots do you see? Come on.
2, 4.
I only see one root. Why are we only seeing 1 and not all 5? Well, 1 is what kind of number? Starts with an R. Real number, and it's rational. So if I don't see roots, that means they probably are what kind of numbers? Complex, imaginary. Okay. So, guys, let's continue on with this. Okay. So look, if I look at this, it looks like it'd be nice if I had a little bit more space. So menu, window zoom. Let's go from say -3 to 3. Okay, that's much nicer. This is on your homework, yes. Right there, okay. So, Okay. So guys, what kind of questions are we being asked about? So first of all, there's no relative min, no relative max. So this is going to be, excuse me, there's no absolute min or absolute max. This would be what kind of maximum? Relative. This would be what kind of minimum? Relative. That would be a 0. Okay. Well, let's find these on our graph. So menu, analyze, minimum. So for the minimum, click to the left and right of that point. Be glad that you're using the calculator and you didn't have to figure that out on your own. Menu, analyze maximum. Click to the left and the right of that point. There we go. How do I find this 0? It looks like it's at 1, but just menu, analyze graph 0. And there we go, 1, 0. So this graph starts out increasing or decreasing? Increasing. It increases until I get to what point? 401. Then it starts to do what? Decrease until I get to 0.524. Then it starts to increase all the way to infinity. So using that graph, I can answer these questions. Absolute max on this one, there is none. Absolute min, there is none. Relative max was negative 401, negative 0.71. Yeah, this is easy stuff, guys. Relative min. All you have to do is read this off. Can you read this number, Kyle? 524, 524 and minus 138. So 1.38. Okay. What are the x-intercepts? What are the x-intercepts here? X-intercept. Where do I cross the x-axis? Where the heck are you getting that from? What is this number right here? This number is 3. 5 is way over here, okay? The only place it crosses the axis right there is at 1, 0. Okay. There we go. Okay. Now, I didn't ask it here, but I will ask it on Thursday. First of all, what's the domain of this guy? Negative infinity to infinity. What's the range? Negative infinity to infinity, okay? Okay, now, what is the interval? So this first interval I'm increasing. So I increase from negative infinity to negative 0.401. So the interval of increase is negative infinity, negative 0.401. And then what happens at negative 0.401? I stop increasing and I start doing what? Decreasing from that point to 0.524. Okay? And then what do I start doing after that decrease? I start increasing from this to infinity. Okay? So, okay? No, you don't do them, okay? So these are all the kind of questions that I'll ask you on Thursday. So, yeah, your calculator will do it. I'll let you have your book on Thursday to do this, okay? I don't know that it'll help you, but yes. Yeah. Pardon me? On Thursday, you've got one question. That one question is going to look a lot like, it's really going to look a lot like one of these we did today, where like this one. Like here's, no, not this one. Yeah, it looks like, yeah, yeah. Guys, everybody, hey, hang on. The problem you're going to see on Thursday is going to look a lot like this. A polynomial that you don't want to use synthetic division. You will put it in with your TI Inspire. You will find the max and min. You will find the zeros. You'll answer these kind of questions. Straightforward, guys. The only thing that's new is the max and min, intervals of increase or decrease, okay? But it's just reading off of the graph, okay? So, yes. Yeah, but you wouldn't have to find them. So hold on just a second. Okay. So, hey guys, the question was, would I give you something that has complex roots? Okay. Yeah, that is very possible. Okay. So something like this, it may have complex roots, but you don't have to find them. Okay. You're only concerned with finding the real ones. So the one that we did in homework, fifth degree polynomial, has 5 roots. My graph only showed me one of them. I didn't make you find the other complex roots. Okay. Now what may happen though is if I give you on the test x cubed plus 1 and I ask you to factor that. How do you factor x cubed plus 1? That's the sum of cubes. So that's going to come up with a quadratic, and the quadratic is going to have complex roots. So you may have it, but you're not going to be asked to graph them. Okay? Okay, that's it for today.